Hey, I'm Neurosurgeon Kazu.
Welcome to The Explainer. Today, we're diving into something literally mind-bending, what a smart brain actually looks like on a purely physical level. We talk about intelligence all the time, right? But usually as this abstract concept, like it's just this invisible aura you either have or you don't. But what if I told you that a highly intelligent brain actually has a distinct, physically observable structure? We are pulling our insights today directly from the clinical experiences of a practicing neurosurgeon, someone who has literally looked at, operated on, and studied countless human brains. We're going to peel back the skull and look right at the physical anatomy of intelligence. Look, before we even get into the anatomy, let's address the elephant in the room. Have you ever caught yourself thinking, man, I'm just not naturally smart, or my memory is definitely slipping as I get older, and there's really nothing I can do about it? These are incredibly common insecurities. We tend to view cognitive decline as this absolute inevitability, and high intelligence as just a genetic lottery ticket. But I'm here to tell you, and our neurosurgeon source is here to prove to you, that this simply isn't true. By the end of this explainer, you're going to have scientifically backed, highly actionable reassurance that your cognitive hardware is entirely in your hands.
All right, let's kick things off with Section 1, the brain size myth.
Check out this number, 1,230 grams. That is exactly how much Albert Einstein's brain weighed. Yep, one of the greatest, most paradigm-shifting geniuses in all of human history had a brain that weighed just 1,230 grams. So why does this matter? Well, it completely shatters our preconceived notions about what intelligence physically is. To put that into perspective, the average adult brain actually clocks in at about 1,400 grams. That means Einstein's brain was physically smaller and lighter than average. Mind-blowing, right? This proves definitively that brain volume and weight absolutely do not equal thinking power. It's kind of like how a massive, chunky desktop computer from the 90s is infinitely less powerful than the tiny little smartphone sitting in your pocket right now. The size of the container tells us literally nothing about the processing power inside. So to find out what actually makes a brain smart, we have to stop looking at the overall size and start zooming in, microscopically, at the density and transmission speed of the neural circuits.
Moving right along to Section 2. The physical structure of intelligence. So if you take a look in a cross-section of the brain, you've got two distinct areas, gray matter and white matter. Think of the gray matter, which is that thin outer layer of the brain, as your processing CPU, or like a massive bustling factory. This is where the nerve cells hang out, and it's where your actual thinking and judging take place. On the flip side, the white matter makes up the inner region. This acts as your high-speed broadband cables. It's the transmission network that passes the signals generated by that gray matter factory from one area of the brain to another. And as you'll see, a smart brain exhibits highly optimized physical traits in both of these distinct areas.
Now zoom in on that gray matter factory for a second. The nerve cells in there chat with each other through microscopic connections we call synapses. In a highly intelligent brain, the physical density of these synapses is just absolutely staggering. The information pathways are woven together like this incredibly fine, super dense net. And this physical density is exactly what allows a person to connect multiple, totally seemingly unrelated solutions from a single experience. It's the literal physical foundation of being a multifaceted problem solver. When someone is super quick-witted, it's literally because their brain has built a denser web of synapses. But here's the catch. Having a ton of dense connections in the gray matter doesn't mean much if the signals are moving at a snail's pace. That brings us to the white matter, and a crucial process called myelination. The nerve fibers that act as the cables in your brain are wrapped in this insulating membrane called a myelin sheath. Think of it like the thick rubber insulation wrapped around the electrical wires inside your house walls. In a smart brain, this myelin layer is physically thicker, and that prevents information from leaking out, which allows electrical signals to quite literally leap forward at overwhelming speeds. The thicker the myelin, the faster your processing speed. It is literally a physical upgrade to your internal broadband.
Now, let's look at the boss of the brain that ties this all together, the prefrontal cortex. Located right up there behind your forehead, this is the brain's supreme command center. It handles your highest level logic, your emotional control, and your deep focus. Neurosurgeons note that in a highly optimized smart brain, the physical cortex, the gray matter right in this specific area, is visibly thicker and far more developed. This high cell density in the command center is exactly what allows someone to sustain deep, complex thought on really difficult tasks without losing focus or just giving in to frustration.
Which brings us to a really fascinating twist. Section 3, the energy-saving brain.
You know how in movies, a genius is always sweating, rubbing their temples, just burning through tons of mental energy? Well, a major clinical insight is that the reality is the exact opposite. A smart brain actually utilizes an energy-saving mode. Because their physical circuits are so highly optimized with all those dense synapses and thick myelin we just talked about, the brain processes information via the absolute shortest possible route. On advanced imaging scans, a highly intelligent brain doesn't look like this chaotic fireworks display. It lights up beautifully and precisely only where absolutely necessary. A smart brain doesn't work harder, it physically works much more efficiently, wasting zero energy.
Of course, even the absolute best factory in the world shuts down without power and supplies, right? A brain can only operate at full capacity when its blood flow and chemical balances are perfectly maintained. A smart brain features a really rich, robust blood flow that rapidly delivers oxygen and glucose, which is the brain's primary fuel, to all areas. Plus, it super efficiently secretes essential chemical messengers. For instance, acetylcholine flows smoothly to lock in memory formation, while dopamine is readily secreted to spark motivation and drive. Without this vital physical infrastructure, even the densest neural networks are going to falter.
Okay, so how do we actually get there? That's section 4. The brain changes at any age.
The absolute game changer here is the magnificent concept called neuroplasticity, and I really want to emphasize the word physically right now. Neuroplasticity is the brain's physical ability to change its structure, form brand new synapses, and grow thicker circuits in response to new knowledge and new experiences. Your intelligence and cognitive abilities are never just fixed in place. Every single time you learn a new skill or challenge yourself, your brain physically updates its architecture. You can literally grow a smarter brain, starting today, no matter how old you are.
So, let's get into the actionable stuff. Section 5, Daily Habits to Grow Your Brain.
It is honestly amazing how simple the inputs can be to get these massive physical upgrades. First off, just 20 minutes or more of aerobic exercise, like a brisk morning walk, releases BDNF. That's a brain-derived neurotrophic factor that actually protects and multiplies cells in your hippocampus, which is your memory center. Second, engaging in fine finger movements, talking, or writing dramatically boosts blood flow straight to that supreme command center we discussed, the prefrontal cortex. Finally, deliberately tackling slightly difficult challenges forces your brain out of its comfort zone, and that physically opens up brand new neural pathways rather than just relying on the same old ones.
But building the hardware is only half the battle, right? You gotta maintain it. Step 1 is totally non-negotiable. You need about 7 hours of high-quality sleep. Sleep isn't just resting. It is a literal physical cleaning cycle where the brain washes away metabolic waste and organizes all those shiny new synapses you built during the day. Step 2 is managing your blood pressure and blood sugar. Why? Because chronic high blood pressure and high sugar physically damage the highly delicate microvessels in your brain. Protecting your vascular health prevents silent strokes and ensures your brain's fuel infrastructure stays perfectly intact.
Let's do a quick recap of what we've covered today. A smart brain has absolutely nothing to do with being big or heavy. It is all about having dense synapses that allow for diverse ideas. It's about thick myelin sheaths that enable lightning-fast processing. It's about a highly developed prefrontal cortex for deep, sustained focus. And it operates as a super energy-efficient circuit supported by rich, healthy blood flow. But above all else, please remember this. A smart brain is a physical state achieved through your daily habits. You literally have the power to physically grow these structures every single day.
As we wrap up this explainer, I want to leave you with one final thought. Right now, literally as you are sitting here processing this information, your brain is already physically changing. It adapts based entirely on how you use it. So, I have to ask, what physical upgrade are you going to give your brain today? Will you take that 20-minute walk? Will you finally tackle that difficult book? The power to build a better brain is literally right there in your hands. Thank you so much for joining me to explore this incredibly cool topic, and I seriously can't wait to see how you put these physical upgrades to use.